Okay, yesterday I showed you the three types of analysis for multi-lane highways and freeways, which were operational, service fluid, service volume, and design analysis. In all these analyses, the first step is to find out the free flow speed, okay, and the second step is to find out the heavy vehicle factor for heavy vehicle adjustment, okay, and the third step is apply one of these equations. Okay, so in all of them, you need FHV, factor for heavy vehicles. That's why I said this is the second step. How do you find out the factor? This is the equation. You need two things here: percentage of heavy vehicles and the passenger car equivalent, EHV. And this EHV depends upon terrain. Okay, I showed you the conditions. How do you decide about the terrain? Once you have decided, if it is level or rolling, we have this table for the EHV. If it is something else, then we have one of these tables. Okay, the difference between these tables is the percentage of the types of heavy vehicles. We have SUTs and we have TTs, single unit trucks and trailer trucks. Then we looked at this example, how we can convert vehicles to passenger cars. We can use FHV, okay, so volume divided by FHV, or you can use EHV directly. You calculate the number of heavy vehicles and multiply with it. Okay. Multi-lane highways and freeways have very long segments. Okay, so it's very uncommon that you have a long segment with one gradient. The gradient may change. Okay, so in that case, we need to combine the gradients, okay, into an average value. Okay. To do the combination or to calculate the average gradient, we use the total height and total distance. Total height and total distance. Gradient is height upon distance, right? Okay, so we need the total height and total distance. In this example, there are how many? Two, right? Yes. Two gradients are here. Okay, for each of them, we see the length, okay, and we see the gradient. Okay, so how do we calculate the average gradient? Now this gives me what? 3002.03. It will give me what? 1000. No. What is this value?
For each 1000 there is 1%.
So this becomes what? This multiplication becomes what?
Distance?
Distance, yes. No, not the distance. This is the height. Okay, distance is 3000. Okay, so same thing for the other gradient. And I said total height upon total distance. Okay, so this is total height upon total distance, which is 3000 plus 5000. How much is that? Okay, so the average gradient is 4.25. Okay, so I will take this for my analysis. Okay, now let's say I have to decide about the terrain for this gradient. Okay, my length is 8,000 feet and the average gradient is now 4.25%. Okay, 8,000 feet is how much in miles? This is the conversion. How much is it in miles? 1.5. So gradient is 4.25%, length is 1.5 miles. Okay, I go to my criteria. Okay, so first of all we need to decide, are we here? Is my gradient more than 3%? Yes. Okay, then I need to see if my length is more than 0.25 miles. My length is 1.5 miles, right? So I am here. Okay, I satisfy this condition. That means I have extended gradient. Okay, so I have to use one of these tables.
First one.
Okay, one of these tables, not the first one. First one was level and rolling there. I have to use one of these tables depending upon the percentage of heavy vehicles. Okay. some more examples of average gradient method. We'll do the same thing. Okay, distance multiplied by gradient to get the height. You add all the heights, divide by the total distance. This will give you average gradient. Okay, the only new thing here is that you can see part A we have 3 gradients. Okay, we have 3 values. You will add 3 heights and 3 distances. Got it? Clear? Any questions? Okay. Now, in these examples, there is no negative gradient. And if the gradient is negative, that means the height is going down. Okay. So when you will be adding the height of the negative gradient will be minus. Got it? What about the distance? Distance is not minus. Okay. Only the height will go minus. Clear? Okay. So now we know now all the equations. We are moving to the 3 analysis we have. Okay. We are starting with operational analysis. Okay. In operational analysis, we are trying to find out level of service. Okay. You can see the last line. Okay. What level of service is expected on this side? Okay. So this is the example for operational analysis. Okay. And the data is given. What was the first step? Free flow speed. Okay. Is it given? Free flow speed is not given, right? It could be given because you can actually go and study the free flow speed. Okay. So it could be given. Right now? No. Okay. So I will now calculate free flow speed. My first step is to calculate free flow speed. Okay, free flow speed for freeways is this. Who are you? See, if I cancel that lecture, today's lecture.
Won't come.
This is very important.
VIP.
We see only 2 or 3 times a semester. Whenever you are done, just let me know.
I came. First month I came.
Huh?
First month I came.
First, your month was 1 day. Okay. So this is how we find out the free flow speed for our freeway. Okay. So we need some values. The first factor is for lane width. Okay. How much is my lane width? 10 feet. Now, should I put 10? No. There's a table. Okay. So I take the value for 10 feet from the table. Okay, how much for 10 feet? 6.6. Okay, so the first factor is 6.6. Okay, the next thing I need is the factor for lateral clearance. Okay, how much is the lateral clearance? Zero, right? Okay, with lateral clearance I need the number of lanes as well. So how many lanes I have? 4. Okay, so I'll go there, 0 feet and 4 lanes. Okay, 0 feet, blast row, 4 lanes, meaning 1 lane in each, 2 lanes in each direction. So my factor is 3.6. Okay, what was TRD? Total ramp density. Is it given? It should be given, right? Okay, so this value is 5. What is the free flow speed? Okay. The next step is to find out the factor for heavy vehicle. Okay, the factor for heavy vehicle, FHV 1 divided by okay. PHV is percentage of heavy vehicles, right? Which is 0.0. Okay. EHV depends upon what? What should I know to find out the value of EHV? I have some tables for EHV, right? I have 4 or 5 tables for EHV. This one, and also this one. So how do I decide which table to use? Depend on the terrain, right? Okay. What did they say about the terrain? What about the terrain? Tell me. Okay. So for rolling terrain, it uses one. Okay. So EHV is 3. Okay. How much? 9, 6. Okay, now the last step, or the one before the last step, is to find out the value of BP, okay, the flow rate. Flow rate is volume divided by peak hour factor, number of lanes, and F. Okay, is the volume given? Yeah. Okay, this value. Peak hour factor 0.95. FHV 0.96. How many lanes? 2 or 4? Why not 4? Each direction. Okay, what is my VP? 1644.
0.7.
Okay, what did I write here? What is this? Passenger car per hour per day. Okay? Yeah?
Yes.
Now we are trying to find out level of service. Okay? For level of service, I must know density. Okay? I must know density. Density is flow rate upon speed. Density is flow rate upon speed. Do I have flow rate? We just found, right? BP is not flow rate. Okay. Do I have speed? Free flow speed. This is one speed. But do we have free flow speed always on the road? Okay. So first of all, I need to find out, is this the speed on the road when the flow rate is this much? Okay. And this depends upon the speed flow curve. Okay. If you are on this part of the curve, then your speed is free flow speed. If you are in this part of the curve, then your speed is this equation. Okay, so first of all I need to find out whether I'm here or here. Okay, what is the difference between these two parts? The breakpoint. Okay, how do I get the breakpoint? This is the equation for breakpoint. Clear? Okay, they are just asking for what? Free flow speed. Okay, this is called capacity adjustment factor. This is called capacity adjustment factor. Right now there is no adjustment of capacity. Right now we don't need any adjustment for capacity because no adjustment is given in the question. Okay, this is the next part, we will come to it. Clear or not? Okay, so right now we'll forget about this factor. Okay, we just use this equation. Okay, so how much is the breakpoint? $1,920. Okay, any problem? Clear? Sure. Okay. Now if I go back to the curve, this is my breakpoint, right? Okay. If I'm on this part of the curve, then my flow rate should be what? Less than breakpoint or more than breakpoint? Less, right? Okay. So my breakpoint is 1920. Okay, and my flow rate is 1640. Okay. So I'm this part of the behind, right? I'm behind. Okay. So that means my speed is free flow speed. So now I can find out density using the free flow speed. Flow rate upon speed. Okay, how much is density now? Okay, now we'll check it with the density for level of service. Okay, so this is my table which gives me the density for each level of service. Okay, we have a freeway, that means the second column. Okay, now look at the ranges, tell me what is my level of service. $31.2 D, right? I'm here, right? In this range. Between 26 and 35. Okay, clear? Clear? Any questions? My level of service is D. What?
Was there a one until the
Wednesday.
which time?
11.
11 until 12, yeah?
Sure. Maybe before 12. We'll finish
Yeah,
before.
better.
Maybe you will not even give it
Oh,
and you will miss the bonus. Maybe.
no,
Maybe.
you'll give us the more stars to focus us.
No, I did not find it. Okay. This was one part of the question. Okay. In the same, so this is okay. Now, if I look at the flow rate, okay, our speed is free flow speed, right? Free flow speed is something good or bad? Good. Now, what is the range of levels of service from A to
D, E. Give him D.
he wants to the lower side or the higher side? This the level of service.
Lower.
It's low, right?
Yeah.
My speed is so good, and the level of service is towards the low side. Okay. So they are telling us that this could be because of the geometry of the road. Okay. The lane width, if I go to the data, you look at the lane width. How much is the lane width? 10 feet. This is the minimum. Less than 10 feet is not acceptable. Even a normal car will not, is not enough even for a car to move, let alone the trucks and so on. Okay, so 10 feet is absolute minimum. Okay, look at the lateral clearance. How much? Zero. Okay, so the road is very narrow. Okay, because of this narrowness, okay, the drivers are very close to each other and their density is higher. Okay, that's why we have level of service D. Okay, if you keep everything same but you increase the size of the road, the width of the road, you will have better level of service. Clear? Okay, so this is the reason. Okay, like I said, this is one part of the question. The second part, now if you see, I told you one of the equations had the factor CAF, right? CAF stands for what? Capacity what? Capacity adjustment factor. Okay. If we have capacity adjustment factor, we have speed adjustment factor. We do not use that. Okay. Why? There was no condition given for that. Okay. There are 4 conditions for adjustment factors: weather, driver population, incident, or work zone. None of them was mentioned in the question. Okay. Now they are saying on this highway we have a weather condition. In the original question, the weather condition was not given. So I did not apply any adjustment factor. But now there is a weather condition. Okay. So how would the result change if the weather has moderate or medium rain? Okay. How would the results change if the weather condition on the road has moderate or medium rain? And I told you earlier this should be consistent. Like most of the year it is like this. Okay? Definitely not bad. Okay? Malaysia, Singapore, those areas. Okay. Okay. Now first of all we need to check what are the things which will be affected by the adjustment factors. Okay. First thing which will be affected is the speed, free flow speed. Okay. So we need to apply the adjustment factor to the free flow speed. Okay. So we have medium rain. Okay, so the first row, right? Medium rain, the first row. Okay. If the data is given, then I will check it with the range. Okay, but now they gave me the condition direct. Okay, medium rain. So for medium rain, now my how much is my free flow speed? How much is my free flow speed? 52, right? Okay, if I look at the table, there is no 52. Okay, can we do interpolation? We cannot. Why not? Okay. Now 52 is on the lower side, right? Okay. In that case, we just take the lowest factor. That's it. One answer. Okay. So now my free flow speed will be changed to adjusted free flow speed, and it will be multiplied. Okay. Adjustment factor is multiplied. So how much it is? Okay, so the first thing which changes because of the weather condition, because of the adjustment factor is the free flow speed. Okay, the next thing which we calculated is the heavy vehicle adjustment factor. Okay, this is the equation in front of you for the heavy vehicle adjustment factor. 2% was the trucks, and EHV was the equivalency factor of the truck. Do you see anything related to weather here? Any adjustment factor here? No. Okay, so move on. Next thing we calculated was BP, the flow rate. Do you see any adjustment factor there? We did not miss anything, right? We did not miss anything. Okay. Then we calculated the break point. We calculate the break point. Okay. If I go to the equation of break point, there was the factor there. Okay. There was the capacity adjustment factor there. I will show you the equation again. But in the equation of break point, the capacity adjustment factor was there. Okay. So it's a similar table. Same values for free flow speed, and we have the same dilemma that we are on the lower side. Okay, so I'll just pick the value which is 0.94. Okay, so my capacity adjustment factor is 0.9. Let's keep it in mind. Okay, now if I look at the equation for the break point, I calculated the break point without this, right?
Yes.
Okay. Now this one is 0.94. So whatever value you have, you multiply with the square of 0.94. So how much is this? 1697. Okay, what was the reason of calculating this? Why did I calculate the break point? For the capacity. I did not calculate the capacity.
Adjustment, for the adjustment.
For the adjustment, I did not do any adjustment last time. For the drawing, I did not do any drawing last time. For the graph, okay, what the graph shows? Yes, tell me. What was I checking from the graph? Break point is? Yes, to decide whether I should use FFS or not. Okay, in the last case, my break point was 1920 and my flow rate was higher. Sorry, flow rate was lower, right? So then I decided, okay, I can use free flow speed. Okay, so break point was calculated to check whether I can use free flow speed or I cannot use free flow speed. Okay, in the previous case, flow rate was less, so I used free flow speed. In this case, is it less or did it change?
Don't use this.
Huh?
Not this, you don't use the fixed.
But what is it now? Is it less or more?
Yes.
It is still less. Okay, so I can use free flow speed. I used free flow speed earlier as well, right?
Yes.
Okay, so will this value change?
No.
No?
Same number will change.
Density will not change?
It will change.
It will change. Why?
Because the free flow speed changes.
Because the free flow speed changes. See, you should come more often. Okay, so now the density will be according to this value. How much? Break point? Flow rate. Yes, flow rate upon free flow speed. We calculate the new break point, and the break point is still more than the flow rate. What new? 1645 was flow rate. Okay, it was flow rate. I was putting flow rate here. We don't put break point here. The only reason for calculating break point was to check.
Yes.
Can I put free flow speed here or some other value? Okay, break point doesn't come here. Yes, how much? 30.5. Okay, so I will go again to the level of service table. My value is 32.5. My level of service is how much? I'm still D. Okay, so level of service is the same. Okay, now because of weather condition, what changed? Level of service did not change, right? The traffic is more or less same. What are the things which changed because of level of service? Density changed. Okay, density increases, that means traffic is becoming slower. Okay, drivers are slower. Okay, their spacing is less, their speed is lower. Okay, and you can see the free flow speed is lower obviously. Okay, so this proves that. So you may not see any significant change, but there is a slight change in the speed and the spacing. Okay. Okay, now we have a multi-lane highway. Okay, so again, 4 lane, there's the median, the volume is given, the lane width, the letter clearance, okay, and 10 access points per mile, 10% trucks, peak hour factor is given, segment has 3.5% gradient and 1.25 miles length, okay. The base free flow speed is given, what is the expected level of service on the upward grade and the downward grade. Okay, what is the level of service on the upward grade and the downward? What will change? Upward and downward, what will change? The sign of the gradient. Okay, and that will change the other things as well. So this volume is for both directions or one direction? No, the volume 2600. Is it both directions or one direction?
No, one direction.
One direction, right? So how can I use it in both in the other direction? What is the volume in the other direction? Will it be the same?
It will be lower.
It will be lower, right? But where is that value then? Where is it? Not necessary to do it. See? Very easy. Not necessary.
Because the given one is for the one in direction.
Yeah. So what we do now? They are saying do upward and downward both, right? They are asking me for both directions.
Maybe
They don't agree with you that it's not necessary to do both directions.
This is the worst case scenario.
This is the worst case scenario. So what do I do with the other direction?
The same.
The same.
It will be satisfied for that. It will be satisfied for that.
Yeah. Okay. Whatever peak hour volume we select for one direction, we assume, okay, we are not doing it for the same hour. We assume that the same volume is expected in some other hour in the other direction. So we will not have 2600 at the same time. So maybe in the morning 2600 is in one direction, upward direction. We can assume around same volume can be expected in the downward direction, but not at the same time, maybe in the evening. Okay, because traffic is two-way, right? Your trip is two-way. Okay, so that's why this is the reasoning behind it. Whatever you have in one direction, at some other time, we may expect the same in the other direction, more or less. Okay, clear? So we will use the same volume, but we will do it for both directions. But the point here is, it's not the same time. It's not the same time. Okay. What was the first step to find out what free flow speed? Free flow speed for multi-lane highways, this is equation. Okay, so equation is different for multi-lane highways. Okay, what did they give me, which I can put, the first factor I need is, the first factor I need in this equation is base free flow speed, right? This is the first thing I need, right? Okay, which is how much? 65. Okay, then I have the factor for lane width. My lane width is 12 feet. Okay, for 12 feet the factor is 0. You trust me. Okay, for 12 feet the factor is 0. It's the same table which we have used for the freeways. It's the same table. Okay. Then we have factor for lateral clearance. S freeway. Now you can see in the question, lateral clearance is given for, how much is the lateral clearance? 4. Where? So both sides are given. Okay. This is the difference between the multilane highway and the freeway. We need both sides lateral clearance. Okay. So both sides lateral clearance 4 and 4 means 8. Okay. And we have how many lanes? 4 lanes. Okay. So 8 feet clearance, 4 lanes. Sorry? Okay. So 8 feet clearance and 4 lanes. Okay. The vector is 0.9. Now they said the highway has a median. Okay. Which condition says it has a median? First table. There are 3 different values, right? Having a median means it is divided. Okay. For divided, the factor is 0. Then I need the access points. How many access points are given? 10. Okay. For 10 access points, the factor is 2.5. Okay. So what is my free flow speed? 61.6. Okay. Second step is find out the factor for heavy vehicles. Now the difference between this example, the last one, is we have to do it for upward and downward both. Okay. Now first of all, we need to check which condition do I have. Okay. So my gradient is given how much? 4 what? 3.5, right? And my length is how much? 1.25. Okay. So first of all, I need to check the terrain. Okay. 3.5 more than 3. Okay. And the length is more than 0.25 miles. Okay. So I have extended grade. I cannot use for level and rolling. Okay. If I could have, then it would make my life easier because level and rolling upward and downward are same. Okay. But life is not easy. Yes. Okay. Now to use one of these tables, I must know the mix of heavy vehicles. Okay. What did they say about the mix of heavy vehicles in the question? What type of mix I have? Standard. Okay. Standard is this one. Okay. Standard is this one. Single unit trucks are more, trailer trucks are less. Single unit trucks are 6 meters, which are normally higher than the trailer trucks. Okay, so I pick a factor from here. Okay, clear? Okay, let us do it for the positive gradient first. 3.5 plus upward. 3.5 is here. Okay, my length is 1.5, right? 1.5. So this one. 2.5. Okay. 2.5. Okay, 3.5, 1.25. Okay, and what is the percentage? No, percentage of trucks. 10. Okay, so 3.5, 1.525 mile length and 10% truck. My factor is 2.96. Okay, so first of all, I will calculate my FHV for upward gradient using okay, how much is this? Okay, this is for upward. Okay, for downward I will use the same equation but the factor will change. Okay, factor will change. The percentage is obviously the same, but the factor will change. Now downward means minus 3.5, right? Minus 3.5. Where is minus 3.5?
No, we want not -2. Calculation.
Hmm? Okay, we have the same problem, right?
Really, assuming -2.
Minus what?
We will take -2.
No, we will not take minus 2. But the factor for these are minimum values. When you reach the last value, this is minimum. Okay, just pick that value. Okay, the gradient is minus 3.5, yes. But after minus 2, it doesn't change. This is what it is. Okay, and same thing on the higher side as well. Okay, after that, it doesn't change. Okay, so we don't need to do any make any assumption. Okay, these tables you will see some other tables as well. Okay, so when you reach the last value, okay, and your value is even below that, we don't assume anything. Okay, this is the value, and why it is not given? Because it doesn't change. It doesn't change. We did the same thing with the z table, if you remember. Okay, we said after this much it is always 1. Yeah, so after this is 1. Okay, so we don't need to have. So I will pick. So whatever it is, after this is my cell. Okay, I'll be looking here. Okay, so my length is 1.25. My percentage of flux is 10%. So my factor is 1.9. You can see even here, no change. Okay, so there is no change here even after that. Okay, so if I put 1.96 here, what will be the answer?
0.912.
Okay, so I have the FHV for upward and for downward. Okay, now I will calculate VP for upward and downward. Okay. Okay, I need the volume, 600. I need the peak hour factor, how much? 0.88. I need the number of lanes, how many? 4, 2, 1, 2.
One direction.
Okay, I need the FHV. So this is where I need to calculate 2L. The FHV has 2L. Okay. So first of all, with 0.84, how much? 175.9. Okay, and the other one will be, you will replace 0.84 with 0.91. So how much?
1623.
1623. Okay. Now we are required to calculate level of service. Level of service comes from density. Density is flow rate upon speed. Okay, I have flow rate, I have speed. Should I calculate density? We need to check the breakpoint. Okay, it's a multilane highway. Okay, it's a multilane highway. For multilane highway, the breakpoint is fixed, no equation. The breakpoint is 1,400. Okay, for multilane highways, the breakpoint is 1,400. Now you can see here in both cases, for upward and downward, my flow rate is more than the breakpoint. My flow rate is more than the breakpoint. So now I am in the other side of the graph. I'm always on the right side. Yes, we are on the right side.
Always in the wrong side.
Okay. Being on the right side means it's difficult. Okay, being right is difficult. So now we cannot use free flow speed. We have to use this equation. Okay. I need free flow speed, I have. Okay. I need what now? Capacity. Okay. So first of all, let us find out capacity. Okay, this is the equation for capacity. Okay, any change of the gradient here? Any effect of the gradient? No. Capacity will remain the same. How much? 2232. Okay. Okay, I needed capacity for that speed equation. I have capacity now. What else do I need? I need a breakpoint which is fixed 1400. I need A value. Okay, the A value is again in the table. The A value for multilane highway is 1.3. Clear? Okay. What else do I need? Free flow speed I have. Capacity we calculated. A value given in the table. Okay. Flow rate we calculate. What else do we need? DC. Okay. DC is this density. Okay. When you calculate density at capacity, this is your DC. Okay. Critical density. DC is critical density, which is 45. Okay. So now we have all the values. Okay, the A from the table is 1.31. Okay, will I have two values of speed or one value of speed? One value of speed? Because of?
The free flow speed, just twice.
No. Now I'm going to use this equation, right? Will I use it once or twice? Huh?
No, right equation.
Because the flow rate is leading, you have to use it twice. Okay, so that means if you do speeds, there will be two different densities and could be two different levels. Okay, how much?
Give him bonus, Victor.
What?
Give him bonus.
I will take your.
Yeah, give him
Give it to
no problem.
them. It's no problem. I can take one from everybody. He's the only one.
Give
Right
him-
or wrong?
You'll bring it and you give him bonus.
He's thinking why did I come?
You will bring A and you will give him bonus. You will take double A.
See, that's the problem.
You give him something.
I had a problem like this.
Really?
Yeah. I submitted the grade, one of them had 102.
Okay, so
102.
honestly.
Yes, yes.
Is the son of Banishtan, maybe?
Huh?
Is the son of Banishtan?
No, no. His whole family is civil engineer. 4 girls and 2 brothers.
That's what.
All of them civil engineers. I don't know why.
So it runs in the genes.
Huh?
It runs in the genes. It runs in the genes.
Yeah, yeah.
57.6.
I think I will put 102.
57.6.
57? Okay. And the other one? So you just now change the VP. So the next step will be flow rate upon speed. Okay, somebody can do that. Flow rate upon speed, how much?
59.5.
59.5. Okay, then density. So you have to make sure that this speed came from this flow rate. Okay, you use this flow rate in this equation and you got this value. Okay, so density would be this value upon this. Okay, don't mix them. How much? $30.5. And the other one? Okay, we are doing multi-lane highway, but the ranges are same in any case. Okay, 30.5, we are here. 30.5, we are here. Okay, 27.3, still we are here. Okay, so the level of service in both cases is D. Okay, so there was an effect of gradient on the free flow speed, okay, or on the speed and the density, but the effect was not so much. So we are still in the same traffic condition. Yeah? Any questions?
What of different, what will choose?
Sorry,
Of different level of service, what will we choose?
we don't do anything. What?
The lowest or of different level of service or densities?
We don't need to choose anything. Both directions have different.
Okay, just one.
Because we are doing the analysis for each direction separately from the start. So if each direction has a separate level of service, doesn't matter. Okay.
Tomorrow section 2 also the same.
No. I don't have meetings every day. One mistake which people usually do in the projects, they do the other way around. They try to merge the two directions, they calculate the level of service. That is wrong. Okay? So level of service is always for each direction. There is no such thing as the highway level of service. Okay? We do it at the intersection, but not for for the highway. And even if you try to combine, we don't combine them simply take it from here, add and do the average. It's not that simple. Okay? Maybe some of the software will give you these results, but that software is not taking simple average, or it's not taking total traffic and so on. You can see it here, you cannot do total. 2600 is going upward, 2600 is going downward. You cannot add them together.
Yes.
Got it? Okay, so this is not possible. We don't do it. Okay, thank you.